Okay, right, so here we've got a question on rationalising the denominator. It doesn't ask you to do that, but it is showing you a fraction with a surd on the bottom. Now, a surd on the bottom is basically not what we want. We want to simplify it, and it actually says show that it can be written like this. Now, I really like show that questions because it means you can kind of ignore it, don't use it, but do this, and then once you found the answer, so rationalise the bottom here, you can see there's no surd on the bottom here, rationalise it, and then if you get this answer and you've shown it nice and clearly, and you know you're okay, that's like 3 marks, you know you've got. So I really like show that questions. The only danger is don't just go straight to that without any workings. Obviously that's not the idea, you need to show it. Okay, so to rationalise the denominator, the key thing is to times it by basically the number 1. Now it sounds really strange, but it means that if you times it by 1 or an equivalent, it means that it doesn't actually change the value of the fraction, but we need to use a value of 1, which will get rid of that surd. Okay, now anything over itself equals 1. So if we always times it by the same as what's on the denominator, but with a different sign. That kind of gets rid of it, because what you end up having is a minus root 8, etc. And I'll show you in a second that, and it gets rid of it altogether. And we'll come back to that. If I times and then times it by I'll just show you some working on here. So 5 times 5, 25. Then you do root 8 times 5, so add 5 root 8. And then if you do 5 then times these, so it's negative 5 root 8. If you can see, that's always going to happen. You're always going to get this and the opposite way around. And the last one to do is just this 2 last ones. So it's root 8 times minus root 8 is just going to be minus 8. Now that's another one to remember. If you are timesing a root by the same root by itself, you're almost squaring it, which undoes the root. If you think about the square root, it's kind of undoing both parts of that, so it equals 8. Okay, so that's simplified. You'll end up crossing out this one. I mean, this is the whole idea of doing it, so if it doesn't happen then you've done something wrong. So you then end up with 25 and the minus 8. So we'll put that back up here. So 25 minus 8, so you just have 17. You can kind of see, oh look, 17, so that's nice. Straight away, you should see that straight away if you've done it correctly. Okay, if you don't, then obviously there's something going wrong. Again, you can come down here and do the working down here for this one. I'm going to do that actually. 3 plus root 2. We're timesing it by 5 minus root 8. Just double check that. Yeah. Okay, so 3 times 5 is 15. 3 times minus root 8 minus 3 root 8. So I just times up by that, by that. You can do this a lot neater, I'm sure. 5 times root 2. And then root 2 times minus root 8 minus root 16. You're just timesing inside. Now 2 times 8, you can see there's we can do something with that. So let's simplify this a little bit. So minus root 16 is going to be is the same as minus 4, because root 16 is 4. So 15 minus 4 equals 11. Okay, so that's what we'll put that 11 up here. You might notice I'm not quite there yet because it's got minus root 2. We'll go back to that in a second. And then you've got root 5, 5 root 2 and minus plus 5 root 2, and then minus 3 root 8. Doesn't really matter that you've got, that's kind of not quite straight. Alright, now it's not quite showing it that yet, and that's what's happened. And you could have dealt with this earlier on, but I didn't. This root 8 here can be simplified because it's got a square number in it. So if I just do minus 3 times root 8, if I reduce this down, this is the same as root 4 times root 2. Okay, and then minus 3 times that. And so if we simplify this down, minus 3 times root 4, see root 4 is the same as 2, so minus 3 times 2 is minus 6 root 2. Okay, so I was just checking where I was with that. Okay, so back here, if I was to rewrite this out now, equals 11 plus 5 root 2 minus 6 root 2 divided by 17. We're still not quite there yet, are we? So something minus over 17 is fine. But these root 2's, because they're the same base number, 5 root 2 minus 6 root 2, they can be simplified. So 5 minus 6 is minus 1. And we don't need the 1 in front of the root, so just minus root 2. Okay, so therefore you've now shown that that can be the same as that.